welcome you all in this presentation related with the subject fundamentals of surface engineering. And you know that we are talking about the surface modification techniques. And among the surface modification techniques, there are three broad categories. In one, where the surface metallurgy is modified, and in second, where surface chemistry is altered as per the requirement, and in third, where the material of the suitable properties is applied onto the surface so that required improvement in properties can be achieved, and this is done through the development of films, coatings and claddings, etc. So, we are talking about the second category of the processes where surface chemistry is modified for achieving the property modification of the surfaces, so that required enhancement in the tribological performance of the component can be achieved. And under that, we have talked about the processes like cyaniding, carburizing, nitriding and carbonitriding. And in these processes, basically we can use the gaseous mixture of the suitable the gases, so that the elements to be incorporated in form of carbon or nitrogen are made available at the surface of the component to be modified. It can use the solid in form of the powders like charcoal, or the energizers are also used in case of the like pack carburizing, or we can use the liquid in form of the salt bath. Since in these processes the required element in form of the carbon and nitrogen is introduced through the diffusion, which is significantly governed by the temperature, and to achieve the higher depths we need the longer time. So, basically the higher temperature and the longer time, these are the two main troublesome areas. It may be in minutes or in hours as per the process. So, since the longer time means higher temperature is a problem, especially in case of the carburizing, cyaniding, carbonitriding processes. We know that when any component given exposure to the higher temperature for longer time, like 850 to 1100 degrees centigrade, then it leads to the microstructural modification of the bulk material also, due to the prolonged exposure at a higher temperature. And this kind of the microstructural modification, if it is leading to the reduction in the mechanical properties, then it is considered unacceptable. Second problem is that too high temperature exposure at a higher for longer time can lead to the loss of alloying elements from the bulk materials. At the same time, it also increases the tendency for the distortion, change, undesirable change in the size and shape of the component. So, and the main origin for all these undesirable features associated with the cyaniding, carburizing, nitriding is the high temperature for longer time. So, it is preferred that we use those category of the processes wherein either the reduction in temperature is achieved, or reduction in time for high temperature exposure is realized, and or which will be fastening or making the process fastering the process or increasing the rate of the diffusion. So, those category of the processes where required change in chemical composition of surface is achieved uh, without using much higher temperature and using the surface modification for shorter periods and using the higher diffusion rate, or modifying the chemical composition using such kind of approaches which will accelerate the chemical composition modification requirements or the mechanism of the chemical composition modification. And for that there is a special category of the processes where basically we use vacuum. So the components whose surfaces are to be modified is kept under the low pressure conditions so that all atmospheric gases are extracted out. So this will be used to create the vacuum and a chamber. So there is a vacuum chamber which will be used to create the low pressure by extracting all the air, and the component to be modified are placed in this chamber. Now the temperature is increased reasonably, maybe like 300 to 800 degrees centigrade, or even lower like 100 degrees centigrade. So such kind of the lower temperatures which will be assisting the surface modification, chemical composition modification of the surfaces with the help of like the gaseous mixture which is being fed. It can use the plasma, it can use ion beams, or the any other material which is to be deposited in form of the atoms. So such kind of the suitable medium is made available around the surface of the component which is to be modified at a reasonably low temperature and for sufficient time. So here the pressure, temperature and the medium which is being used for surface modification plays a crucial role in achieving the desired surface chemistry modification for required improvement in the surface properties. So basically there are three things which are used for chemistry modification. One is the chemical reactions at the surface, and this is basically used in the chemical vapor deposition process. This is used this approach is extensively used in case of the the tool inserts, where multiple coatings or the single coating layers are deposited over the carbide tools. So the coated tools are basically manufactured using the CVD process, and it uses the chemical reactions to form to introduce the elements required at the surface so that the suitable compounds at the surface and near surface layers can be formed for enhancing the surface properties. And then it can also use the vapors. So here the elements to be deposited are evaporated by heating, and then they are accelerated or ionized in form of ionized. These metal vapors are ionized, and then they are deposited over the surface of the substrate. So those category of the processes where vapors of the target materials to be used are called physical vapor deposition processes, and in short these are termed as PVD and these are termed as CVD. Then we can also use the ions of the suitable the constituents like the nitrogen or argon gases are ionized. So basically it uses the ions of the suitable medium, and they are directed at a high speed towards the surface of the substrate for modifying the surface metallurgy as well as the surface chemistry. In case of the processes like ion implantation. So these are the three the kind of the mediums which are used for modifying the surface chemistry, and accordingly the different processes are used. And when the material a target material or the material to be coated is used in form of the atoms, and then they are deposited over the surface of the substrate, the process is called sputtering. So through by so these the atoms of the material which are to be applied on the surface of the substrate are produced using the suitable means, so that they can be applied or deposited on the surface of the substrate. In this case, they will be deposited at the surface, and then subsequently at a higher temperature the diffusion will facilitate the compositional modification of the surfaces of the component which is being considered for the improvement of the surface properties. Apart from these, we also use since the use of the vacuum eliminates the possibility for the nitrogen and oxygen which are normally found in the ambient condition, and at a high temperature these gases normally causes the oxidation or the nitride formation at the surface. So such kind of the oxidation and the nitride formation will be leading to the loss of material and loss of the elements from the functional surfaces which are being modified if the high temperature exposure is given under the ambient condition. But when the vacuum is used in this category of the processes, these gases are eliminated from the vacuum chamber. So despite of use of the high temperature, absence of these gases doesn't cause any loss of the material or the elements due to the oxidation or the nitriding of the or nitride formation at the surface because of the vacuum. Since all these processes vacuum is used invariably, so in these processes the vacuum chambers, which are normally large in size so that the number of components can be modified in one go, and vacuum pumps. These are the two main components of this category of the processes where vacuum is used, whether it is PVD, CVD, ion implantation, sputtering, etc. But there is another, you can say, the limitation side of this category of the processes, and not very thick layer of the modified composition is achieved. Like we have seen in case of carburizing nitriding, which can be up to like 1500 micrometer. For carburizing 1.5 mm is very common. For nitriding maybe like 200, 300, 500, 600 micrometers or so. But this is true for the carburizing or nitriding or cyaniding kind of processes. But when we use vacuum based processes, these are limited to very thin layer. So compositional modification of the surface and near surface layers happens up to a very less depth, and this depth of the modified composition may be maximum or so up to like say 5 micrometer. Otherwise it is usually limited to the 1 micrometer. So when for the applications where such a thin layer of the modified surfaces is sufficient for performing the expected function or required function from the surfaces, then only this kind of this category of the processes are used. So especially those applications where with this much depth of the modified surface is sufficient to perform the intended function, this kind of processes will be okay. Otherwise we will be using another group of the processes where we really require the greater thickness of the modified surfaces. So the common surface modification processes where the vacuum is used. So we can say the vacuum based surface modification techniques is one is the like vacuum assisted vapor deposition is one process, and then ion implantation is another process where nitrogen or argon ions are normally used. So in that case it is termed as nitrogen ion implantation. Then sputtering is another process where the target material is bombarded with the ions, beam of ions, and then the atoms which are released from the target material are deposited on the surface of substrate in case of the sputtering process. And then we have ion beam assisted sputtering. Another process is ion beam assisted implantation, and then ion plating, then chemical vapor deposition. And so all these processes where vapors are used, they which are made available through the evaporation of the metal, then it can be ionized, or it can be those vapors are accelerated and applied onto the surface of the substrate so that the coatings can be formed on the surface of the substrate, and subsequently diffusion at a higher temperature will be facilitating the compositional modification of surface and near surface layers. So physical vapor deposition processes. So these are the some of the processes where the vacuum is invariably used for modifying the surfaces. Now we'll be talking about the one particular vacuum based surface modification process where vacuum assisted vapor deposition process. So in this case, in case of the vacuum assisted deposition process, we use the large chamber like this, and this will be connected to the vacuum pump to create the required vacuum, and this is the chamber. In this chamber we use the heating arrangement of the this heating arrangement which will be providing the required heat, so that so this you can say power to heating system, and here the metal which is to be applied onto the surface of the substrate. So the coating material or the material which is to be applied is brought to the molten state, and then it is, due to the higher heat, it is evaporated. So the gases which are being formed or evaporated from the from this layer from the molten bath will be moving up at low velocity towards the surface of the substrate. On the top of it we put the substrate or the component whose surface is to be modified. So the low velocity moving gases will be impacting with the under surface of this surface of the substrate, and after that they will get deposited. So the metal which is evaporating and impacting with the surface of substrate, it will get deposited over the surface of the substrate. So the energy with these vapors is very low because of the low velocity. So low kinetic energy with these the gaseous particles which are moving up and impacting with the surface of substrate. This is moving at the low velocity. So because of these two key properties of the gases which are being used to modify the substrate surface, the kind of the bond which is created between the substrate and the coating which is being formed, in this case this bond is very poor. So the substrate coating bond is very poor, and at a high temperature, once this coating is formed, it will be getting diffused inside the substrate gradually. So now here we will have the certain good aspects and the negative aspects related with this approach. Like the material which is to be applied onto the substrate should have the low boiling point to form the vapors. So low boiling point, and therefore chromium, copper and zinc kind of the metals which can be evaporated to apply on the surface of the substrate can be used, and these are the common metals which are deposited on the surface of the steel substrate primarily for improving the corrosion resistance. Once this coating is applied, since this kind of the coating is formed using the vapors which had low kinetic energy due to the limited velocity, so the bond is poor, and therefore this kind of the coatings cannot be used for the applications, especially when the stresses at the functional surface is high, because they will get removed in that case easily under the higher stress conditions. So such kind of the chemical composition modification of the surfaces is good, especially when the stresses acting on the functional surfaces is very low, like corrosion condition. But if the stress magnitude is high, like under the adhesion, abrasion and erosion, then this kind of the coatings will not survive and they will get removed from the functional surfaces easily, and this is primarily attributed to the poor bonding of the coating material with the substrate. But apart from this one aspect, there is another good side, that this kind of during this process the temperature of the substrate is limited to the 100 degrees centigrade, so which is quite low as compared to the other carburizing and nitrating kind of processes. So the low temperature will be favorable from the integrity or the maintenance of the substrate structure and properties. So the damage to the substrate in form of the distortion tendency, drop in mechanical properties or microstructural modification, all these adverse effects will be very less with this kind of process, because very minimum rise in temperature. The rise in temperature is limited to the 100 degree centigrade. So there is no thermal damage with this kind of processes, to the substrate. Now some of the positive points, some other positive points related with this vacuum assisted vapor deposition process is that low or limited rise in temperature of workpiece or substrate less than 100 degrees centigrade. It needs the low vacuum. This is another favorable side, so that we don't need much time to create the required vacuum, and limited work is to be done to create the vacuum which is required. So the use of the low vacuum is another positive side related with this energy. It requires less energy to modify the functional surfaces. However, the low energy associated with the vapors will be causing the negative side related with this process. And on the other hand, the negative aspect or the disadvantage associated with this process is that low energy or kinetic energy of vapors leads to the limited substrate coating bond, and because of this it cannot be used for the higher surfaces. So good for the limited stresses, not for high stress applications like abrasion, adhesion and erosion conditions. Another thing is that this process is very slow, so it takes longer for modifying the surfaces, and there is no automatic cleaning of the surfaces. There are some of the surface modification techniques where the inherent nature of the process is such that surface impurities are damaged, broken, and the surface is cleaned automatically. But in this case, where vapors will be directly depositing on the substrate to form the good bond and the good surface modification, it is necessary that the surfaces are cleaned properly so that all the impurities from the functional surfaces can be removed. So the one disadvantage associated with this process is that there is no arrangement for automatic cleaning, but we need very proper cleaning of the functional surfaces for surface modification. So the positive side is that low rise in temperature, limited rise in temperature, limited vacuum and limited energy consumption, but the negatives are that the limited kinetic energy of the vapors causes the poor coating and substrate bonding, and because of this we cannot use such kind of the surface modification technique for the higher stress conditions like abrasion, adhesion and erosion, and the process is slow, so it takes longer, as well as there is no automatic cleaning during the process, so we need to clean the surface properly. So now I will try to summarize this presentation. In this presentation basically I have talked about the vacuum assisted surface modification techniques, basic principle of the vacuum assisted surface modification technique, and we have also talked about the details of the vacuum assisted vapor deposition process, how it can be used to modify the composition of the functional surfaces so that the improvement in surface properties can be achieved. Thank you for your attention.